Okay, so here are our conclusions. We came up with 150 cases per order will minimize our inventory costs. In order to do that, we have to place 8 orders over the course of the year. You notice this last one says find the minimum inventory cost. So I gave you a couple of options. If you look up further on your page, it says that our inventory cost, the one that we started off, was $5 times however many cases plus the $75 ordering fee. This will give you one order, but we want all the orders, so we're going to take all of that and multiply it by R, which is the number of orders, plus 8 times the average number of orders you have in order reorder period. So what you could do is you could take this and plug 150 in for all the X's and then 8 or all of the R's, and that'll give you a dollar amount that you can plug here. Okay, here's an example that where you don't have to use both of your variables. So you notice this says IC of X. Okay, this is the formula that came further down. So I said, what happens if we just plug the 150 in? And you can actually see it, 6,000 plus 9,000 over 150 plus 4 times 150. That dollar amount would go up here into your minimum inventory cost. All right, so really the only thing that we have left is this proof that I'm going to ask for, likely worth about 25% of your points. All right, so we want to do the number line, the first derivative test. That's what we've been talking about this entire time, right? So I'm using the first derivative of my inventory cost to tell me what the inventory cost looks like. So your question probably is, well, we have 2 numbers that we could use, the 150 or the 8. You always, always, always use whatever number came out when you took those 3 steps. Look, here's step 1, take your derivative. Here's step 2, set your derivative equal to 0, and then the rest of it is step 3, where you solve for your variable. So when we solve for our variable, there it is, 150. So we got X equals 150, right? That number goes on your number line. Don't put any other number there. So this is 150, and the least number that you could have of case of orange juice is 1, right? And then just pick a number bigger than 150, 200. And as the name suggests, you're going to plug that into your first derivative. All right, so what was my first derivative? Let me show you that. We already have that. You can just scroll, just take your finger and follow up until you see IC prime. I'm just going to show it to you. Here's my derivative when I did my first derivative test. Take the derivative, step 1, and at the very end is my rewrite of IC prime. So I'm going to use that. Okay, so IC prime of X equals negative 90,000 over X squared plus 4. All right, let's plug these numbers in. I need to see your work, please. IC prime at 1 equals negative 90,000 over 1 squared plus 4. I want that number. And also IC prime at 200, which is negative 90,000 over 200 squared plus 4. All right, so let's find those 2 numbers. Let's put this one down here. Okay, so this one's pretty straightforward. This is negative 89996. So a negative value there tells me that my original function IC is decreasing. And let's try this next one. Negative 90, 1, 2, 3 divided by 200 squared plus 4. I got that one is positive 1.75. So I get a positive derivative right here, which means IC should be increasing. I'm looking at a local max, a local min rather. Right there at IC, right there at X equals 150 cases of orange juice.